Let's have some fun with Oozie. So I've already kicked off my Hortonworks sandbox environment and connected to it through SSH, logged in as Maria_dev. So we've done that a million times. So what we're going to do with Oozie is tie together two actions in Hadoop. We're going to do a scoop extract from MySQL to get the movie lens movie information, the information about each movie ID, their title, and their release date. And then we'll tie together an action to that actually uses Hive to analyze that data and extract all of the movies that were released prior to 1940. So first we need to make sure that MySQL has some data for us to play with. So to check on that, let's just do MySQL -u root-p, and the root password is Hadoop, and do a show databases here. Now, if you already see a movie lens database, then you already have the data you need in there from prior lectures. But if you're like me and you had to reset your environment since then, let me refresh your memory on how to get that data back in here. So let's just type in quit to get out of here and download the SQL script that contains all the commands to populate that database. So we can type in wget http://media.sundog-soft.com/hadoop/movielens.sql. And that is basically a SQL script that will populate the movie lens database for us. So now we can go back into the MySQL interface. Again, the password is Hadoop. And we first need to tell it that we have strange character encodings because of foreign films. So we need to say set names, quote UTF-8, quote semicolon, and set characters set UTF-8, semicolon. All right, now we can create our database. Create database movie lens. And we can use that database, correct syntax. And now we can execute that script to populate that database. So we can say source movielens.sql, and that should set everything up. Let's make sure that it's all there. So let's do a show tables. Yep. And just to take a peek of what's in there, let's say select star from movies limit 10. And sure enough, there's a little peek of what's in MySQL that we're going to extract using Scoop, driven by Oozie. So movie IDs, movie titles, and release dates is the format there. Pretty simple stuff. Finally, we need to make sure that we have permissions on this database so that Scoop can actually access it. So to do that, we'll say grant all privileges, make sure you spell that right, on movielens.star to single quote, @ single quote, localhost. Wow, I really can't type today. Single quote, semicolon. Just like that. All right, so now we're ready to move on. We can quit. And let's go and get our Hive script next. So to do that, we can just say wget http://media.sundog-soft.com/hadoop/oldmovies.sql. All right, let's take a peek at that, shall we? So let's say less oldmovies.sql. And here is our Hive script that we're going to use within our Oozie workflow. And what it does is it first drops any existing movies table that might exist in Hive, and then it will create an external table. So if you remember in Hive, when you make an external table, it just sits right on top of an extract that you already have on disk. It doesn't make a copy of it. So we're saying we're going to create a Hive table just based on what got dumped into the user MariaDev movies directory. And that's going to be populated by Scoop, just pulling data right out of MySQL and into that directory. So after Scoop extracts the movies data from MySQL, this Hive script will just create a movies table based on that extract, okay? And it tells it the specifics of what the column names are, what their formats are, and what the delimiter is, okay? Very straightforward stuff. And at that point, we're going to say, create a directory that is passed in as a parameter called output, and that's going to be set up through our properties file for the Oozie job. And what we're going to output into that output directory is the results of the following query. Select star from movies where release is less than 1940, January 1st, and order by release. So that will give us all the movies released before 1940 in the movie lens dataset, ordered by release date. So that is the Hive script that we're going to run as part of this Oozie workflow. All right. So let's actually get Oozie set up itself. A couple of things we need to do here. So first of all, let's get the actual workflow file. And to do that, all we need to do is wget http://media.sundog-soft.com/hadoop workflow.xml. All right, and that's the actual XML file that defines our Oozie workflow. So let's take a closer look at that. Actually, I'm going to load this up in a proper XML editor so we can look at it in prettier terms. So let's take a look at what's going on here. So we have the usual XML header stuff, and it says that we're going to include a workflow application kind of document here. So this XML file contains a workflow app named Old Movies. Now it starts with a start node, and the start node just says, where do I start from? And we're going to say we're starting from the node named scoop node, which happens to be right here. It's an action that contains a scoop configuration. And you can see it's actually passing in the job tracker and name node properties as parameters from the properties file. This prepare block is worth mentioning. So you can actually have a prepare property here that contains a command to run before it actually runs the scoop job. And in this case, we're going to see if there's an existing movies directory, which is where our output's going to go. And if so, it will delete it. So we don't have to worry about old data polluting our new results. You can set up any various properties, any environment variables that you might need for this job. And finally, the command property is actually what gets run by scoop. So this is exactly the sort of thing we would have run if we were running scoop by hand on the command line. It would just be scoop import -- connect, the actual driver that we're using. And we're saying we're going to extract the movies table with just a single mapper. That's all it does. So that's all there is. And it says that when we're done, we're going to go to the Hive node next. And if there's an error, we'll go to the fail node instead. Okay? So that's the entire syntax there. We have a scoop node action that contains all the configuration that we need for scoop, including the command itself. And if it's okay, it will proceed to Hive node. If it's not okay, it will go to the fail node. Let's say it's okay. We go on to the Hive node, which is structured similarly. So we have now a Hive action here that's been defined. And its parameter is just where the output is going to go. So remember in our Hive script, we had a $output within it. And this is what sets up what that output directory actually is. We also have a prepare block in here that deletes the existing results if there are any, to make sure that we have a clean slate to work with. And again, if we're finished, what we're going to do is go to the end node, and if there's an error, we'll go to the fail node. Now, if we do have a failure, here's the fail node, which just puts out an error message that prints out any details about the failure. And because it's a kill type node, it will actually stop the workflow at that point. But if everything went all right, we proceeded from the scoop node to the Hive node and then to the end node, which is an end type node, which just means end the workflow with no errors. So there you have it, a little walkthrough of the actual Oozie workflow.xml file that defines what we're going to do as part of this Oozie job. So let's go back to our terminal. The other thing that we need is our properties file to actually run the job with. So let's get that as well. wget http://media.sundog-soft.com/hadoop/job.properties. And we can take a look at what's in there, job.properties. So this contains all of the various variables that we saw within that workflow.xml file. So here's the actual URL, including the port number for the HDFS name node for the Yarn Resource Manager job tracker. So that's running on 8020 and 8050 of sandbox.hortonworks.com, which is just the DNS name for our little sandbox environment here. We're going to say that we're going to use the system library path because it does depend on some things that are in there for actually getting scoop to work. And finally, we will give the path of the actual workflow.xml file itself. So this is saying under HDFS, I am going to look under the user Maria_dev file for a workflow.xml file, and that will define this workflow that I want to run. Now, obviously, in the real world, you'd probably have things a little bit better organized where individual jobs lived in individual subdirectories, and you probably wouldn't be running under the Maria Dev account, but maybe the Oozie account or something else. But for the sake of illustration, let's keep it simple. Hit Q to get out of that. All right, so we do need to upload our workflow.xml file into HDFS so that Oozie can actually use it. So to do that, we'll just say Hadoop fs-put workflow.xml/user/Maria_dev. And that will upload our workflow XML file to where our properties file said it would be. We also need to put our Hive script where it expects to be. So we'll say Hadoop fs-put oldmovies.sql in the same place, /user/Maria_dev. All right, now we're not quite ready to run it yet. There is one more thing we need to do. So in order for Scoop to be able to connect to MySQL, we need to install a MySQL connector that Oozie can see, and that is actually not installed by default on Hortonworks. So to do that by hand, we can say this: Hadoop fs-put /usr user /share/java /mysql-connector-java.jar, and we'll put that under /user /lib_2016-1025-075-203/scoop. And you might say to yourself, self, that's a very specific number there. How can I make sure that's the right one? Well, let me show you. So let's go into Ambari before we hit return on that line. 127.0.0.1 We'll log in as admin. Password, whatever it is that you set it to. I almost gave you my password there. Good thing I caught myself. Let's go to the files view. So if we go to user, and then Oozie, and then share, and then lib, this is the shared library folder for Oozie. And depending on what version of Hortonworks you have installed, that may very well be a different number. So if it is, make sure you reflect that number in what we entered in the console here, okay? So for me, it was lib 2016 102.507.5.203, but if that's a different number for you there, make sure you substitute there what it should be. Okay. So let's get that copied up. All right, and finally, we should have everything we need, but we need to restart Oozie. Everything's always complicated, isn't it? Because we put that new dependency in there. So let's go up to the Services tab here in Ambari. Go to Oozie. Go to Service Actions and say Restart All. So let's confirm Restart All and wait for that to restart so we can pick up that new MySQL connector library that we installed into Oozie. That'll take just a few seconds. All right, and we're good. So finally, we are ready to actually kick off our Oozie workflow. Let's go back to our terminal. And from here, we can just type in Oozie job-Oozie http://localhost:11,000/Oozie, and that says where we're going to run the actual Oozie console from, the web view, -config, and this will be the path to where we have our job.properties file on our local file system, not HDFS, /home/Maria_dev/job.properties -run to actually say we want to really run this workflow right now. Let's kick that off. And it should give us back a job ID. And now if we go back to our browser, we can go to 127.0.0.1:11,000/Oozie and take a look at the Oozie console. You can see that our job is there in running status, and there's not a whole lot to see in this console. It's all read-only, so it's really just status information. You can't use this to actually edit things, but you can take a look at them. So let's actually take a peek. You can see that the Scoop job is running right now. And one thing that's cool is you can actually go to the Job DAG tab here and see a little picture of the directed acyclic graph that we just set up. So you can see ours is very simple. We have a start node that goes to a Scoop node that does our Scoop extract from MySQL to extract all the movies table into a HDFS. And then from there we go to a Hive node that creates a Hive table on top of that Scoop extract and just extracts the old movies from before 1940. And from there it goes to end to finish. So let's go back to job info here. And you can also do things like look at the job definition, which is just a view of the actual XML file itself for the workflow.xml if you want to refer to it here. And various properties that are set by the frameworks. The log, and if there are any errors, if the job fails, you'll find that under the job error log tab here. But no errors yet, thankfully. Let's close out of this and hit refresh to see what's going on. Oh, it disappeared. It went from active jobs. So if we go back to the old job, all jobs tab here, we can see that it's now moved to all jobs and it is succeeded. So you can click on that to see more information about it. You can see that sure enough, it hit the start node, finished that OK. It left the scoop action with an OK status, and it left the hive action with an OK status, and then it went to end. So it appears to have worked. Pretty cool. Let's take a look, shall we? So let's see what the actual output was of this thing. We can go back to Ambari and go to the Files view. And we configured it to actually put the output. This was in our properties file under user MariaDev, old movies, right? So this should be our final output right here. Let's open it up and take a look. Sure enough, we have some old movies sorted by release date. Pretty cool. So it turns out that the oldest movie in our database is the movie M from 1931. Duck Soup. Wasn't that a... I can't remember if that's a Marx Brothers movie or a Charlie Chaplin movie, but anyway, rings a bell. So it worked. We have old movies here from before 1940, managed by Oozie. So this is an Oozie workflow running for real. We could run that on repeatedly if we wanted to, and we could also set up an Oozie coordinator if we wanted to actually run that at some regular frequency. But there you have it. We got our hands dirty with Oozie. Let's just clean up our mess here a little bit like we always do. Go back to our terminal here. There's actually nothing to clean up, really. I mean, we can just leave those files there. They're not going to hurt anyone. So let's just exit out of the sandbox, and from there we can actually shut down our VirtualBox. So there you have it, Oozie. Again, what we did was we actually did a scoop extract and a hive analysis on that extract, tied together as an Oozie workflow, and we ran it and took a look at it in the Oozie web console. So that's hands-on with Oozie. Very powerful tool if you're an administrator and working in production. All right, let's move on.